right, so here we go. I'm going to work through this here. Okay. So, the test you'll see is a little bit of a different kind of format. Whoop, there we go. The test is a little bit of a different kind of format than what we're used to. There's going to be some select all that applies. You'll see here as well, like there's going to be places where we're going to check things, like whether they're a function or not. That's going to be like a little checkbox, basically. There's more traditional multiple choice as well. Here again, here's some boxes that we can check and stuff like that too. Here we're going to be filling in blanks, so those are blanks to fill in and stuff like that. Okay. Let's see here. Here's again some like a blank to fill in with a bank of possibilities and stuff like that. So it's a little bit different. Okay. There's some, like a graph thing to answer questions about. Here's like different parts and things, and there are some things with different parts. Okay. So we have individual questions, but we're also going to have some more extended kind of questions too. Okay. So let's go through this, and I'm just going to start calling on people. Okay. And we'll see how we do here. So, question. What? You got this, Dylan? All right, Dylan. Dylan wants this one. All right, Dylan. What are we going to do here? Okay, -3 on this line or this axis? The y-axis or the f of x axis in this case, since we're in terms of f of x. But that's fine. -3. Okay, right there. Up to 1, 2, 3, right there. And we can keep doing it, right? Up 1, 2, right 1, 2, 3. Up 1, 2, right 1, 2, 3. And of course, instead of going up to right 3, we can go down to left 3. Okay, very good. And we'll then connect the dots. And yes, I'll pass out rulers here in just a sec. Okay. So there's the graph. All three of them on a ruler. Does anyone not want a ruler? Okay, you all just take a ruler. Question.
On this test.
On this test.
We do not indicate that it is a line that goes on.
Like, should we include arrows and stuff like that?
Are there points taken off for that?
It's a good thing to do, I would say. Yeah. I don't know. I don't know the answer to that question, but I would suggest. I don't know the answer to that question.
But it's a good.
It's a good thing to do. Though. You should put arrows. Yes. Exactly. Yes. Put the arrows there because our domain. We don't have a limited domain or anything like that, so we assume the domain is all real numbers. Okay. And the range for this would also be all real numbers, right? Because you can see it's going to keep going up and down. So there's no number that's excluded. Okay. Number 2. Sequences. Now that's familiar, right? We just started talking about this stuff. Okay, the sequence 27, 24, 21, 18, ... can be represented by which of the following? Select all that apply. So there's going to be potentially more than one here. Okay, so let's go to Hannah T. So Hannah, what kind of sequence do we have here, you think? It is arithmetic. How can you tell? Okay, so great. That down by 3 every time, that is the, what do we call that thing? When it goes down by 3 every time, that is the common difference. So the common difference is -3. And what's our first term here? 27. Okay, and remember, I will be giving this formula to you. A sub n equals d times n minus 1 plus 27, right? That's our formula. Oops, I should have put a sub 1 there, but oh well. Sorry, this should be a sub 1. Now we'll put our information in. So a sub n equals d, -3, times n minus 1 plus 27. Okay? So there's our formula that describes that sequence. Okay. Matt S., does this match to anything over here? Does this match to anything over here? N minus 1. Yeah, my apologies there. Yes? Which one does it match to? Okay, the first two. So are the first two exactly the same, Matt? What's different about the first two? A plus 3, right? So these two are not the same. So this can't match to both of these, right? So which one does it match to, Matt? The first one here or the second one? The what? Okay, what makes you say that? Right, and it's a negative 3 for our common difference there in front. So yeah, it's got to be this one. Okay, it's the first one, not that one. Okay. What about 3n plus 24? Does our equation match to this? Catherine, I see you shaking your head yes. Is that you're shaking yes, right? Okay, how do you know, Catherine? What can we do here? What can we do over here to see if it matches to this equation right here? What can we do over here? Yes, distribute that negative 3. You got it, Catherine. Great job. Negative 3 times negative 1, positive 3, plus 27. Okay, right? So negative 3 times n. Oops, I put an x there. I meant to put an n. Negative 3 times n is negative 3n. Negative 3 times negative 1, positive 3. And then we have the plus 27. Okay, and then, Catherine, if we combine like terms here, we're going to have negative 3n plus, what's 3 plus 27, Catherine? 30. Okay? So, does this match to anything over here, Catherine? Yeah, this one right here, right? So there's an answer. This one's not an answer. Okay? All right, so we've got 2 correct answers so far and 2 incorrect answers. Let's look at these 2. What is this? How is this defined here? What method is this that they're using to define the function? Is this explicit like these last couple were? Is this explicitly defined? No, this is using what? What do we call this method here? Starts with an R. Recursive. This is recursive, right? Okay. Remember, the recursive function is supposed to give you the first term and then how to find the next term. Are both of these recursive functions correct? No. Which one is the correct one? The last one, because we're starting, our first term is 27. Okay. This one says the first term is negative 3. That's wrong. So this one is correct. So this one, and this one are right there. Okay. So you'll notice here, folks, that thing required you to know how to do explicit and implicit together. Okay, explicit and implicit as well, together. Okay, questions on number 2? No? Okay. All right, number 3. Number 3, solve for x. Select the inequality that represents the solution. Okay, let's go to Erica. So Erica, if we have 7 minus 1 over 3x is less than 15. How will we solve this, Erica? What should we do to both sides here? If we're trying to solve this inequality, how should we solve? Get the x by itself. Subtract 7 from both sides? Okay, minus 7 on both sides. What's going to be left over here, Erica? Okay, so yeah, negative 2. Don't forget that minus sign in front. Negative 1/3 x. And then 15 minus 7 is 8. Okay, and then Erica, what about from here? What should we do now? Divide both sides by what? Negative 1/3. Very good. Okay, I'm going to cancel those out. Okay, right away, we're in an inequality, and when we divide both sides by a negative number, alarm should be going off in your head. We have an inequality, we're dividing by a negative. What do we have to do? Flip the inequality sign around. Okay, so now it's going to be x is greater than, and then 8 divided by negative 1/3 is negative 24. Okay, so the answer is what here? Which one? The first one. Okay, the top there. Okay, very good. All right, number 4. Questions on that one?
So it's when you're dividing or multiplying?
When you divide or multiply both sides by a negative number. When you're multiplying or dividing by a negative number, you got to flip that inequality sign around. And folks, I mean, again, students forget this. Okay, look at your answers here for number 3. They have the equation, they have the inequality with the sign flipped. Okay, or not flipped, I should say, right? You see it was less than, and we had to flip it for greater than. They still have the less than one there. So my point is, be careful, right? Just because you think you saw the right answer for the multiple choice, or you found one that's there, that doesn't mean you're right. You may have made a common mistake, which is how we find the other answers, the wrong answers for multiple choice. Okay, so be careful. All right, number 4, a relation is given in the table below, so you can see, and there's a blank here, and then 4 and 8. If the blank space is in the table is replaced with any of these ordered pairs, would the relation would be a function? Would the relation then be a function? Okay, so what do we remember about functions? What makes a function a function? Every x value has to what? Go with, and how many y values? It can go with at most one other y value. Okay, so let's plug in that 3, 8 here. Okay, so man, we got a lot of people out today, and this is holding me back. Let's go to Sean. Sean, if I put 3, 8 in here, okay, maybe I'll use pencil to do that. If I put 3, 8 in here, is this going to be a function? No. Okay, so where do we have an x value going to 2 different y values?
4, 8, and 3, 8.
Okay, 4, 8, and 3, 8. That's okay. So when you have 3 going to 8 and 4 going to 8, that's going to be okay here. Imagine graphing this, right? -2, -3 would be like about here. 0, 0 would be here. And then 3, 8 would be like, well, let's see, 1, 2, 3. We'll say 3, 8 would be like up here. And then 4, 8 would be 1 over and up here. You see how this passes the vertical line test still, Sean?
Yep.
This still passes the vertical line test. So it's not the y that repeats, or a repeating y value isn't bad. It's if we see a repeating x value there. So this is a function. It is a function. Okay, it is. I'll put that in green there. This is a function. Okay. All right. Let me get rid of this here. What about 0, 3? Not a function. Why is that? The x value of 0 goes to 0 and to 3. So Sean, just so I can show you like a visual representation of that here. Okay, again, we're on the next point here, Sean. If I do -2, -3, we're back to here again. If I do 0, 0 right there, 0, 3, it's going to be like right there. You can see these 2 points. Oops, sorry. These 2 points are right above each other, right? There's 0, 0. There's 0, 3. You can see they're right above each other. A vertical line intersects both. So this is not a function. Okay. And then finally 2, 5. Again, I will erase this and put in 2, 5 there. Okay. Mark, with 2, 5 in there, is that relation a function now? Or is it not? Yes, it is. That's right. It still is. That's right, because every x value goes to only one y value there. Okay? And so, yes, function again.
So that's the rule. Every x value can only go to one y value.
Right. So basically, if you see like a repeated x value, Ms. Mulcahy, in your table, that means that's normally not a function then. Unless it happens to go to the same exact y value as the other x value
Right, I got
does.
confused because I saw that we were putting 8 in twice in the y, but we were only using 3 once.
Right. It was 3 to the 8 and 4 to the 8. That's okay.
Okay.
All right, moving on here. Number 5. Bless you. Okay, Katie is going to make personalized T-shirts. She starts her business by buying a screen printer for $500. She pays an additional $14 for materials for each T-shirt. She is planning on selling the personalized T-shirts for $25 each. Write, then solve an inequality to find the number of shirts Katie would have to sell in order to make a profit. Okay? So she had to spend money to buy the printer and for the supplies for the shirts. Then she's going to make money when every time she sells a shirt, she makes $25. So she's got costs and she's got, income too from the selling those shirts, sales, right? Okay? To make a profit, you want the amount of money that you make to relate how to the amount of money that you put out, kind of thing. So costs versus sales. If you want to make a profit, what do you want to be true about your costs and your sales? Sales to be higher than your cost, right? You want your sales to be higher than your cost. So let's think about how we can write an inequality here. Let's look at the ones that are given. Okay, one of these four is right. Okay, so which one of them is the correct representation here? Let's go to Kendall. What do you say, Kendall? And again, I'm blocking off the, let me block off this question right here. So which one of these four represents this situation? Which one do you think? And again, you take time to read through it again if you need to there. If you're not sure, you can say that too. That's fine. Second one? Okay, so let's see here. No, that's right. That's right, Kendall. Yeah, that's right. Good job. Okay, so let's see what Kendall said here. So 14x is how much she has to spend to get the materials for the shirts for every shirt. And then she also had to spend $500. So her total cost is that 14x plus 500. Okay? Then what she makes is she sells the shirts for 25x. So we put that on a separate, on the other side here. We're going to compare these two things. So again, this is costs, and this is like her sales. And don't we want sales to be bigger? And with the inequality, the way it's pointed, the 25x, we want it to be bigger than that 14x plus 500. So this is exactly right, Kendall. Good job. It is that second one. Okay, well done. Okay, questions on that one? Again, she spends this and this total, and then she makes this much for every shirt she sells. Okay, so let's go to the next one here. Katie needs to make and sell blank to make a profit. So in other words, now we need to do what here, Reagan? If we want to actually now find the number of shirts that she needs to sell to make a profit, what do we need to do with this inequality?
Solve it.
Solve it. You got it. That's right. So can you lead us through those steps in here? So we've got 14x plus, sorry, let me just write it out here.
So
Okay?
I subtract 14 from both sides.
14x, right, from both sides. So we're left with 500 here is less than, and that's going to be 11x. Okay?
And then divided 11 from both sides.
Okay, divide 11 on both sides. Good. And I'm going to, so 500 divided by 11. Did you get what that was?
It's a decimal, so 45.4.
Okay, we'll say 45.4 there, approximately. And that's less than x. Or we could flip the inequality around and say x is greater than 45.4, right, if I flip everything around there. Okay? So then, Reagan, what's the answer then here? Which one of these four answer our question based off of our inequality there?
Probably just the 45. It's not a negative.
Okay, right. Yeah, we definitely don't want to answer a negative. A negative number of shorts doesn't even make any sense. Now, let's take a look here. So, Reagan, if we say 45, is 45 greater than 45.4?
Yes.
So, this is like 45 and 4/10. You see what I'm saying? So, 45,
No.
it wouldn't be, right? But is 46 greater than 45.4? Yes. So 46 is the answer. 45 won't quite be enough. It's not going to be quite enough. So she's got to actually sell 46 to make a profit.
But she doesn't count 46.
What's that?
She found 45.
No, we're asking how many does she have to sell?
Yeah, how many will she need to sell? Yeah. Yes. Yeah. Okay. Questions on any of that? All right. Number 6 then, the equation C equals 5/9 times the quantity F minus 32 is used to convert temperature from Fahrenheit to Celsius. Okay? When F is the temperature given in degrees Fahrenheit and C is the temperature given in degrees Celsius. Yeah, if you guys ever go to Canada, right, and they tell you, ooh, it's, 30 degrees outside, and you're like, ooh, that's cold. Actually, that's really hot, because they give it to you 30 degrees is in Celsius. And so 30 degrees in Fahrenheit, well, we can see what that converts to here. But, let me see here. 30 divided by 5/9 plus 32. Yeah, so that's 86 degrees Fahrenheit. Okay. So just be careful with that. If you're ever going in Canada, you hear them tell the temperature on the radio or something like that. It's weird because you're like, wait a minute, and you realize they're in Celsius, not Fahrenheit. But anyway, the point here, we're supposed to take this, okay, and then find an equivalent form of the conversion formula here. Okay? So let's look here. For example, in this one, what's different about the formula than what we were originally given here? What have they done here in this example? Okay. What variable did we solve for in the first one? The variable is solved for what letter? Or the equation is solved for what letter here? This is audience participation time. Let me maybe call in some. What's that? Okay, well, so this one's solved for F, right? And this one's solved for C. So let's solve this. Let's solve this for F and see if we end up with this right here. So C equals 5 over 9 times F minus 32. Okay. So, all right. So let's solve for F here. So how would we solve for F here? What's our first step going to be, Simon? What do you think here? How should we maybe go about getting that F by itself?
Take the 5/9 and multiply it by F.
And yeah, so distribute. Very good. Okay. So 5/9 F minus, and then 32 times 5 over 9. Ooh, 17.777777. So I'm going to hit math, enter, enter there. See, 32 times 5 over 9. So I'm going to hit math, enter, enter, and we get 160 over 9. Okay. Ooh, wait a minute. I see this over in my little bank there. Where is it? Second one. So, aha, that's one of the answers. Okay, you see, this formula that we started with is the same as this one, and so there's one of our equivalent formulas right there. Okay, sorry, Simon. Keep it going. What do we do next here now? What should we do? Sorry, if we want to get the, again, if we want to solve for F, kind of like this one, solve for F, what do we got to do here to solve for F? Get the F by itself.
I guess go ahead and put subtract by F for both sides.
Okay, I see what you're doing there. And get it on the same side as the C or something?
Yeah.
Okay, we could do that. We're subtracting 5/9 F from both sides. So, okay. So after doing that, we now have C minus 5/9 F equals negative 160 over 9. And if I look over here, I don't see anything that looks like that one. Okay. How can we go about here, Simon, continuing to get that F by itself? Let's get that F by itself. So what else can we do here? Subtract C from both sides. Okay. Negative 5 over 9 F equals negative 160 over 9 minus capital C. Okay. And then what? What can we do here now to get the F by itself finally?
Divide by -5/9.
Yeah, divide by negative 5/9. So divide that, divide that, divide that. Okay. So if you're going to type this in your calculator, make sure you use parentheses here. Okay, so I'll show you how we're going to type that into our calculator. Let's see if I can get this to show simultaneously here. There we go. So negative 169, so parentheses, negative 160 over 9, divided by negative 5/9. Okay, just like that. 32 is what we get. How about that? Okay, and then here I'm going to divide negative C by negative 5/9. Now, what number is really in front of the C here? A negative 1. So negative 1 divided by negative 5 over 9. And we get 1.8, or as a fraction, 9/5. So positive 9/5 C. Okay. So what else does this match up to? Anybody see? There's one other one that this matches to. Yeah, second to last one right there. Okay. And there's one more here that this actually is okay with. This one is equivalent to. This middle one right here. We get this middle one if we subtracted 9/5 from both sides there. Right? If we subtracted 9/5 from both sides, we'd have negative 9/5 plus F over here, and then just a 32 there. So actually that middle one as well. Okay? That one's a little bit tricky to see all those folks. I don't really have a good strategy for that other than just keep your wits about you there, okay? Keep your eyes open, while you're doing these problems and when you're manipulating it around here, okay? There were 3 different steps here that were true, that worked. So, question, Ms. Mulcahy?
I don't think so.
No? Okay, sorry.
No, I had one. But I
Okay,
didn't.
change your mind. Gotcha. Okay. All right, moving on. Let f of x represent a linear function with a y-intercept at 0, 6 containing the point -2, 3. Okay? The graph of g is represented below. So, folks, this is where reading is going to be important. Okay, not that it's never important, but I feel like a lot of times, we get kind of like on autopilot, right? And you're just like, oh, let f of x be this. Oh, look, there's f, bless you, right there. Is this the graph of f? Is this the graph of f? It is the graph of what function? G. In fact, if you want to help yourself out, maybe just write g of x there. I'm going to put little arrows there too, just so it does keep going. But anyway, we'll just say that's g of x. F of x is this other function, okay? This other function right here. So there's 2 different functions we're talking about here, okay? Which is the correct comparison of the rates of change for the functions? The rate of change for f of x, blank, the rate of change for g of x. So you can see f of x is greater than, is less than, is equal to, cannot be compared to, okay? When they say the rate of change for the function, and we're talking about lines, what is the concept that discusses or that talks about the rate of change? What is the rate of change of a line also known as? Yes, it's the slope, okay? So Daniel, what's the slope of this line right here? Yeah, 5 over 5, you're saying? So if we look, it does kind of look like we're going up 1, right 1 every time, but not quite, right? So here we have a point at 2, 0, or 0, 2, I mean. If we go up 1, right 1, it doesn't quite look like it's on the grid there. And if I go up again, I can see, oh, it's definitely not up 1, right 1. Okay? Definitely not.
No, it's 4, 5.
Oh, it's,
5, 4, my bad.
okay, so, yeah, 5, 4, exactly right, yeah. So we're going to go, there's a point right here, and then identify another point right there, and just count it. 1, 2, 3, 4, 5, 1, 2, 3, 4, okay? So the slope of g of x, okay, is 5 over 4. So I'm going to write that down here, 5 over 4. Okay, right here. And you can count it, 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, and again, we're going up 5, right 4, so those are both positive directions. Good, Daniel. Okay, now we have to come up with the rate of change for f.
I can try doing that.
Mark, do we know what the rate of change of f is?
Not yet.
We don't, okay, but what do we know about f?
We do know f of x
Mm-hmm.
is a linear function with the y-intercept
Of 0, 6.
0, 6 and 2, -2, 3.
So we have 2 points that are on our line. How can we use 2 points that are on our line to find the slope of that line?
You only need to use one of them.
Okay, what do you mean by that?
I thought when you have like 2 points, you use like one of them when you plug it into like the.
Oh, I see. But we're trying to just find the slope, though, and we already know the y-intercept. So in fact, we don't need like I see. I think you're talking about when we
So
find.
you find the slope of -2 and 3.
Okay, so what's the slope formula, Mark?
Slope formula x y2 y1.
y2 minus y1 over x2 minus x1, right?
Yeah.
So what's our y2 in this case?
y2 would be 3.
3. What's our y1?
6.
Good. What's our x2?
-2.
And our x1?
0.
Very good, Mark. 3 minus 6 is -3. -2 minus 0 is -2. -3 divided by -2, positive 3 halves, right? Because positive slope. Okay,
Can you
so,
put that down a little bit? I'm sorry.
okay, so, Mark, is the rate of change for f, is it equal to the rate of change for g?
No.
No. Can they be compared? Or can they not be compared? Is this an option for us now? We can compare them, right? We know them, so we definitely don't want to say that one. So it's either greater than or less than. Is 3 halves greater than 5/4, or is 3 halves less than 5/4?
3 halves is greater than 5/4.
It is greater than. Okay? If you don't like fractions, you're like, I don't know how to tell which one's bigger, which one's smaller. Type 3/2 into your calculator, hit enter, get the decimal. Type 5/4 into your calculator, hit enter. Boom. Easy to compare now. What's bigger, 1.5 or 1.25? 1.5, right? It's like $1.50 versus $1.25. It's better to have $1.50 than $1.25. Okay? Use some conditioner, Mark. Yeah. It's dry out, you know? It's dry air. Question, Kendall? Yes.
Can I go after Kendall?
You can go now, Mark, yes. Yes. It's weird. It's weird that you didn't have to go until someone said something. That's strange, but okay. All right. Let's go to who haven't we heard from yet? Tyler L. Tyler, it says select the rate of change for the given table. There's our table, and we're supposed to select the rate of change. Okay, Tyler, how would you go about doing this here? If we want to try and find the rate of change of this table, what should we do?
Select 2 points.
Select 2 points. Which 2 points would you like to use?
3, 1, and -6, 7.
Okay, perfect. And then what would you do with those points?
You do the y2 minus y1 and x2 minus x1.
Yes, very good. Remember, we are told that rate of change and slope are the same thing here, folks, okay? Now, it doesn't tell us that this relationship is linear, so we are kind of assuming that, but I think that's what we have to do here. Otherwise, we wouldn't do it. So, okay, m equals. You said, what was on top that you wanted to subtract?
-6.
Careful, it's y2 minus y1 on top, x2 minus x on the bottom. So what should be on top?
So then it would be 7 and then 1.
Minus 1 over.
And then it would be 3 and negatives? No, wait. It would be -16.
Good, yes. Keep your order the same way that you did it before. Exactly right. 7 minus 1, 6. -6 minus 3, -9. I don't see this answer down here.
Divide it.
Yeah, so divide it, right? Simplify the fraction. Bless you, Miss Mulcahy. Bless you. Okay, simplify that fraction. So 6 divided by -9, math, enter, -2/3. So the answer, Tyler, is which one?
This is the 4th one.
The 4th one. You got it. Good job. Okay. Questions on any of that? All right. Turn the page. Okay. Number 9. Okay. Number 9. Christina is saving for a new bike. She already has some money saved for the bike and will continue to put a set amount into her savings account each week. Her savings can be modeled by the expression 20W plus 250. Okay? And we're supposed to then match each expression with the corresponding description. Okay, so in other words, that expression we talk about there, the 20W plus 250, that's got a meaning there. Okay, it's got meaning there. Okay, so what does the 20... Well, actually, let's just do it this way. So let's go through it again. Also, sorry. Calculator is not working for me. There we go. So, again, she's saving for a new bike. She already has some money saved for the bike and will continue to put a set amount into her savings account each week. Her savings can be modeled by the expression 20W plus 250. All right, so let me go to Dylan. Dylan, 20W, what does that represent in this problem? Or actually, Dylan, if you want to give me any of these things, what do any of these represent and match them over here?
20W equals how much money or the amount Christina saves.
Okay, so 20 times W, that's taking 20 and multiplying it by the number of weeks. And you're saying that's the amount she earns each week? Or she saves each week? You see what I'm saying? So let's stick with that though. What is the amount she saves each week? $20. So the answer would be just the 20 by itself, because that's what she's saving per week. Okay? Do you need Ms. Mulcahy?
Yeah.
Ms. Mulcahy?
Or one of you.
Okay. Yes. Okay? All right, so that's B. Very good. Okay, let's go to somebody else here. How about Shepard? What do you say here, Shepard? Can you come up with any of these other ones? So, again, A, C, D, or E. Which one of those? Pick one of those and then match to here, or pick one of these and match to here, kind of thing. Can you figure one out there? Again, that's her savings expression right there. Okay, 250 is D, the total amount saved for the bike. Well, that is, but remember, she's adding to that 20 times W there. So that wouldn't be the total amount saved. That's what she started with saving. So that would match actually to what? It would match to A, the amount of money she already saved, right? She's got to 250, and she's adding money to it every week. So this is actually A here. Okay? Does that make sense, Shepard? Okay, Shepard, what does represent the total amount saved for the bike over here? The last one. Very good. The total amount saved for the bike is D. Very good. Okay, and then let's go to Reagan. Okay. Again, you've got C, the number of weeks she needs to save money for the bike, or E, the amount she saves without the initial savings. Which one of these two here goes with, pick one and then try and match to here. So.
All right. So 20W would go with C.
Okay, so C says the number of weeks she needs to save money for the bike. Is 20W, is that strictly a number of weeks? It's going to be $20 times number of weeks, so the answer is going to be dollars actually. When you do 20 times W, it's going to tell you how much money she saved. So 20W should actually be what? E, the amount she saves without the initial savings. Yeah, E. Okay, and that means W then has got to be what?
C.
The number of weeks. Okay, yeah, W is the number of weeks. That makes sense. C. Okay, E back D. E back D. Okay. Questions on number 9? Okay, let's go to number 10 then. The Youngstown High School track team is training over the summer for the 100-meter sprint. The athletes kept track of their best sprint time and how many days of training they completed. The coach recorded the time and days trained of 9 athletes in the table below. Identify the correct... She's a girl. You have to wait for a boy to return. Okay. Unless I'm making an assumption that I shouldn't be, but you can correct me if I'm wrong. But anyway, I apologize if so. Back to this. The coach recorded the time, blah, blah, blah. Okay, there's your data. Okay, identify the correct regression model for the data. Using the model, determine the time in seconds it would take for a student to complete the sprint after having trained for 7 weeks. Okay, so the correct regression model of the data is, we've got 2 options to pick from here. We have 2 options to pick from here. Does anyone want to take a guess without, what should we do here to find our answer? Put it in the? Yeah, like the stat stuff, right? Sell some cold lemonade. We're going to use sell some cold lemonade here. Now, does anyone want to try and predict which one of these 2 will be the answer based off of our data here? Anyone want to try and make a prediction? First one or the second one? First one or second one? Anyone want to make a prediction? There you go, Dylan.
Which one's the
Y value? Y value would be the sprint time, and days of training would be the X value. Anyone want to take a guess? 1 or 2? You know which one it is already? But because you did in your calculator? Okay, well I guess you can't take a guess. Ella says 2. The second one?
I say 1.
Say 1. Anyone else want to take a guess? All right, so we have 50-50 spread here. Well, we'll see. Let's put it into our calculators. Okay, so yeah, sell some cold lemonade. That means sell. We press stat. And then the E in sell is for edit. And then LL in sell is for list 1, list 2, right? So 5, 20, 20, 22, 60, 60, 70, 90, 100. Okay, and then 19, 14, 16, 17, 13, 12, 13, 12, 10. Okay. Sell. after cell comes sum, and for sum that means we press what? Stat, and then cold, calc, and then lemonade, linreg x plus b, hit enter, enter, enter for me, got to hit enter a couple times there. And then there's the answer. Okay, so number 1, it turns out, is the correct guess there. Okay, number 1 is the correct guess. You have to round that 0.075 to a 0.08, and then 17.729 becomes 17.73. So it is that first one there. Scott, do you want to kind of clue us in about how you figured out or why you thought that was going to be the one?
Let's see the chart.
Yep, sorry.
So I guess that because 23 is way too high of a starting point.
Okay, compared to what the data is right here.
Yeah.
Whereas 17.73 is a little bit closer.
Yeah.
Yeah, that's a good thing. Remember, our y-intercepts, right? They're kind of like the starting point here. And so, yes, we were 5 days into training, and that was at 19. And so, yeah, it's going to be kind of a bit, it's going to be a little bit tricky here to think, well, maybe, but yeah. I see what you're saying there. Not a bad thought there, right? Yes. Okay. All right. Yes, you may. When using the model from above, so again, we're using this model, it would take an athlete that is trained for 7 weeks, blank, to complete the 100-meter sprint. And you see you have some options down here. How can we answer this question? What should we do here? We're told a time of 7 weeks of training.
Plug in S, or no. Plug in 7.
For X?
Yeah.
Okay, so we're supposed to plug in 7 here, right? Because again, remember our X is the days of training. Y is the sprint time. That's what we're trying to solve for is Y here. So yeah, we're going to do F of 7? Wait, why are we plugging in 7 again?
7 weeks of training.
So, but wait, what is X measured in?
Days.
Days.
So you'd have to plug in 7 times 7.
Yeah. We actually have to plug in 49 here.
Yeah.
Okay, what?
Maybe if you were listening, you'd probably.
Miss Mulcahy was busy listening and writing.
I'm going to let that one pass.
So, 7 is a number of weeks, but all the data we've been putting in here was a number of days. Okay? So, if it's 7 weeks, we have to take that 7 and times 7 days in a week to get a number of days here, and we plug it in. That is the key.
That's tricky.
Yes, it is, and I don't like it, but that's the way it is. Okay? So 13.81 is what we end up with when you plug in 49. Okay, I think we plug in 49 there. Okay? So you see I plug in 49 for that function there. All right? Okay. I also want to say I think you guys are doing a good job here so far. I know this is not the most exciting thing. Tomorrow I will let you guys work together with someone else on the review on the computer, okay? And then Thursday we'll take time to go over it, okay? So thank you guys for doing so well. We're not done yet. But I just wanted to say thank you at this point, okay? Because you guys are putting a lot of effort. Yep, go up.
Oh wait.
Right there, or you up. Okay. All right, go ahead. Turn the page. Okay. And Kate and Matt, did you guys get that right for number 10 there? You're supposed to plug in a 49, not a 7. Okay, you caught that? Okay, good. Just checking to make sure. Good. All good? Okay. Number 11, solve the equation below for t. Oh, solving equations, easy. I'm going to rapid fire people here. Let's go to Tyler L. Tyler L., first step here. What do you say to do to solve for t?
Multiply.
Okay, we're going to distribute what number? What are we going to distribute here? What's the number in front of the parenthesis right there? What number is right in front of here?
1.
A -1, right? Yeah, so we're actually going to distribute a -1. So we have t minus 7 plus 3t plus 5 equals 2t plus 10. right? That is a minus in front of the parentheses, so the minus distributes. -7 plus 3t there. Okay, great job, Tyler. Moving to Mark T. Mark. Now what are we doing, Mark?
Now we are combining like terms.
Oh, excellent use of vocabulary there, Mark. What goes together?
Let's see, the -7 and the 5.
Okay, it makes -2. And then what else?
The t and the 3t.
3t and 3t make
4t.
4t. 40? 4t. I get it. Okay, very good, Mark. Let's move on to Ella. Ella, next step.
Add 2 to 10.
Add 2 to both sides. Beautiful. Next up, Tyler L. again.
Subtract 2,
Subtract 2.
both sides.
Subtract 2.
T.
T. Oh, I was confused because I didn't see a 2 up there. I saw a 2t. Just playing with you, Tyler. I know you meant that, but, I just want to make sure you say what you mean and mean what you say, All right, let's go to Simon. Simon, last step.
Divide both sides by 2.
Yes, sir. What's 12 divided by 2, Simon?
It is 6.
6. Very good. T is 6. Final answer. Okay. Questions on that? All right, moving on. We're going to finish number 12, and then we'll call it quits, okay? Finish number 12, call it quits.
And then there's a few people that didn't give me warm-ups at the end. If you have them, you can give them to me.
Okay, number 12. A soccer ball is punted from 2 feet off of the ground and can be modeled by the function h of t equals -16t squared plus 32t plus 2. Right away, looking at this function, what's the relationship that we see here? It is linear, quadratic, or exponential?
Exponential.
Ooh,
Quadratic.
yes. For quadratic, Mark, if you see a 2 in the exponent, that means quadratic. If you see an x or a t in the exponent, that means exponential. Or,
Just the other one.
yeah. The other one's linear, so if it looks like the equation of a line,
Oh.
right? So that'd be an x to the 1 or t to the 1. So if you saw this, for example, Mark, just 32t plus 2, that's linear. But when we throw in that square term, now it's quadratic. Okay? Okay, so anyway, sorry. T is time, h of t is the height, right, at t seconds. So part A says find the height of the ball after 1.5 seconds. What should we do, Catherine, to do that? If we want to find the height of the ball after 1.5 seconds, what should we do with this 1.5?
Put it with a T in.
Yeah, plug it in for t in the function. So we'll say h of 1.5 equals -16 times 1.5 squared plus 32 times 1.5 plus 2. And then calculate it up. Make sure you put parentheses around your substitutions there. Okay, and if we finish it off there, we get 14. And of course, in this case, it's going to be 14. What should our units be here? 14 what? Daniel, what do you think? 14 what? 14 what? What unit should it be here? Well, yeah, which one? It's one of those two. Feet, because we're talking about a height here, so it's in feet. Okay, very good. What about letter B here? What does h of 2.06 equals 0? What does that mean in the context of the problem? H of 2.06 equals 0. So that 2.06, what variable is that replacing? The t. So we're saying t is 2.06. We're saying h of 2.06 is 0. So what is this saying? What is this saying here? What is this telling in the context of the problem?
It's telling us that t equals 2.06.
Okay, and t stands for what?
T stands for seconds.
Okay, number of seconds. So at 2.06 seconds, what's happening? What's the 0 mean? 0 is the...
The feet off the ground.
So at 2.06 seconds, the ball is 0 feet off the ground. Very good, Mark. Or in other words, it's on the ground, right? It's on the ground. There you go. All right. And we'll stop there. We'll stop there. So we're going to finish through 17 tomorrow. Okay, I would like you to work on number 13. Okay, I would like you to work on number 13 for homework tonight. Just number 13, that's it. But there's a couple parts there. Okay, so number 13 for homework tonight. You want to take it home, you said?
Yes.
You're going to lose it?
I don't know how I lost the other one. I'm so good at keeping track of it.
Hey guys, before you go, I think there's one of them was Ben or Daniel or Shepard.
I know.
Or Scott.
It's
You have chances.
Kendall sold it. Well, at least Kendall could give the money for it.
Alrighty then.
Why did you give me that?
I'll get that, Simon. Sorry, 1 second.